Today we're looking at how to write exponential functions from a graph or from a table. So on this first one, you can see here, if you look at the graph, it follows this curve just perfectly, and all of the numbers are nice whole numbers. So I know that this one's going to be pretty easy to write by hand. So what I'm going to do is I'm going to go ahead and I'm just going to make a table of the points so that I can see them easier. So like this first point, 0, 3, 0 is x, 3 is y. And just keep doing that with all of the points in order. 112, 248, 3, 192, 4, 768. Okay, so now let's go ahead and let's look at what pattern we have here. So obviously we know that the x's are increasing by 1. And since the x's are increasing by 1, when we find the pattern of the y's, it's going to be really easy to write our equation. So to get from 3 to 12, we're timesing by 4. And 12 times 4 is 48. And if I check in a calculator, 48 times 4 does get 192. And 192 times 4 does get 768. So since it is adding by 1 and multiplying by 4, what that tells me is when I have this format, my b value is 4. This is my growth factor. It's growing 4 times each time. So that's how I know my b value is by the pattern on the y's. And then my a, remember, was my starting value. And so this 0, 3 is my y-intercept. And because of that, that tells me my a is the y-intercept, which is 3. So my a is 3, my b is 4 to the x. So that's my equation. Now it wants to know what the population will be after 12 hours and after 5 days. Okay, keep in mind, if you look at this, the x-axis, it shows you that x is in days. So 12 hours equals half a day. So if we want to know what it will be, we plug in 0.5 in for x. And so we do that in a calculator. So we take 3 times 4 to the 0.5. And we get 6. The reason we plug in 12 is because 6 bacteria is because this is in days, and so 12 hours is half a day. That's why we don't plug in 12, because it's not in hours. So then when it wants 5 days, that's easy because it's already in days, so you just plug in 5. So 3 times 4 to the 5th is what you type in your calculator. So after 5 days, there are 3,072 bacteria. Okay, so on this one right here, it says this table shows the temperature, which is Y is temperature in Fahrenheit, of coffee X minutes after pouring a cup. So use technology to find a function that fits the data. All right, specifically when it says use technology, right here, that tells me to use a graphing calculator. So remember that if you have an iPhone and you're at home, you can always use the app Calculate 84 to pull up a graphing calculator. I'm going to get mine pulled up right now. Okay, we learned how to do this back with linear regression. So a little bit of this should be a review. So what we're going to do is we're going to go and we're going to press the Stat button and then hit Enter where it says Edit. Just hit Enter. And if you have stuff in here we want to clear it out, move your cursor up here to L2 using the up arrow, and then hit Clear, Enter. And then move your cursor up here to L1, go up and over, and hit Clear, Enter. All right, type your X values into L1, and type your Y values into L2. I'm just typing each number and hitting Enter. Watching for typos. Okay, pause the video if you don't have your data in, get all your data typed in, and then press play. All right, so from there, what you're going to do is you're going to press Stat. You want to go over to where it says Calc right here. So use the right arrow to go to Calc. And we are using exponential, so go down until you get to the one that says EXP. It's 0 on mine, exponential regression, and hit Enter. And it says X's are in L1, Y's are in L2. Go down to Calculate, where it's flashing on Calculate, and hit Enter. So here's my equation. My A is 173.95. Let's call that 174. And my B is 0.9. So 174 and 0.9 to the X. Or if they change variables, it could be to the T. But this said X and to the Y, and so that's how I know my variables are still X and Y. So it wants me to predict the temperature of the coffee after 10 minutes. So just plug in 10 and type that in a calculator. All right, and I got 60.7 degrees Fahrenheit after 10 minutes.